Hello everyone and welcome to the explanation for worksheet 2B. Now this is the second and final worksheet for week 2. We're not all the way through unit 2 yet, but this is the beginning of it. So, excuse me. All right, so let's talk first of all about number 1. So number 1 says, state the two large rules that dictate the domain and range of a function. So for domain and range, the biggest things that you have to remember are you can never divide by 0 and you can never take the square root of a negative number. We do have a workaround for taking the square root of a negative number, and that's imaginary numbers, but we're not talking about that here. So if that ever comes up, don't start using I or anything like that. Just say, no, this is not possible, because there's no negative number that you can square to get a, or no number that you can square to make it negative, okay? So, looking at this for the first set of problems, all I want you to do is state the domain. So domain are the numbers that you're plugging in. So what for all of these problems, we're gonna look for problems. And what I mean by that is we're looking for situations where we might be dividing by 0 or taking the square root of a negative. Well, for number 3, is there anything like any division or any square roots in here? There aren't. So you can plug in any number you want and you'll get something out. You'll never get a error message or something like that. So what we say is we go from negative infinity to positive infinity, or in other words, every number that exists will work for this. Okay. Number 5, we do have some division going on. Most numbers will work for this. The only number that is going to screw this up or make it not possible is -5 on the bottom. So if you plug in -5, you'd have -5 plus 5, and it would be 3x divided by 0, which is impossible. So what we're going to say is every number in the world works except for -5. So the way we write that in set notation is we go from negative infinity, all the negatives work, all the way up to -5. We put a soft bracket on -5 to show whoever's looking at this that -5 is not included in that set. So everything up to -5 is good, but not -5. So like -5.1 is okay, but -5 exactly is no good. Then that U means like and, or and this set and this set. So then we have to talk about the positive numbers. So once again, we're going to start at -5 with a soft bracket because -5 doesn't work, and we're going to the right forever. So we go from -5 to positive infinity, and that is your complete answer. Okay, number 8. So number 8 is going to have two numbers that screw it up because we have two different divisions here. The first one that's going to screw it up is when x equals 0, because you would get 1 over 0. And then the other one that's going to screw it up is when x equals -2, because underneath that 3, if you had -2 plus 2, that would be 0, and that would be 3 divided by 0, and that's no good. So two numbers don't work. Well, if you need to draw a number line for this, I think that's helpful sometimes. So I drew a number line down here at the bottom. I put a hole or an open dot at -2 because -2 is no good. And I put a hole at 0 because 0 is no good. So every other number in the entire world works except for these two. So to describe the region on the left, I'm going from negative infinity all the way up to 2, but not including that -2. So soft bracket there. I put a U for and, or the union of. Then we go from -2 to 0, and we're not including either of those endpoints. So we do soft bracket, -2, comma, 0 with a soft bracket. Then we do another U, and we're going from 0 to infinity, or 0 till forever. So if we do that, soft bracket 0 to infinity with soft bracket. So that is all done. Okay, number 10, we're going to have two things that screw this up. The first one's easy. We've been talking about dividing by 0, so you can't have a 2, because 2 minus 2 would be dividing by 0, and that's no good. The other thing that's going to screw this up is any number that's smaller than -1. And the reason I knew that is because underneath that square root, if we plug in a -1, we'll get -1 plus 1, and it'll equal 0. Well, can you take the square root of a 0? You can. The square root of 0 is just 0, so that's okay. But any number smaller than that is going to make it no good. For example, if you plugged in, like, let's say negative 5. Negative 5 plus 1 would be negative 4. The square root of negative 4 is not possible. So negative 4 is not going to work for it. So any number smaller than that negative 1, which made it 0, is going to be bad. So I put this all on a number line again. The negative 1 now is going to have a closed dot. And the reason it's closed is because we plugged in negative 1, we got a 0, and square root of 0 was okay. So the negative 1 is good, but anything less than that is bad. So that's why my line isn't going to the left of that. I put an open dot at 2 again because everything but that 2 works. So all of my numbers are going to be to the right of negative 1 and to the right of that 2. So the way we write this is that region in the middle is a hard bracket at negative 1 because of the closed dot, and negative 1 works. All the way up to 2, soft bracket, because 2 doesn't work. We say union, or and. Soft bracket 2, and then to the right forever, which means comma infinity, and that's our entire answer. All right, so number 11. What we're doing here is we're just looking at the function, and then I think they give us this graph, and we're just stating the domain and range. So the domain on this is numbers that we're plugging in for x. So if we look at our x-axis, it starts at 1 and then it goes to the right forever. Well, 1 looks like it's included. There's no holes or anything, so we're going to say 1 with a hard bracket, and then to the right forever is just comma infinity, and that's done. Same trick for range, but now we're looking at the y-axis. So this one starts all the way at 0, and then it goes up forever. It goes up slowly, but it goes up forever. So we do 0 with a hard bracket, comma, infinity with a soft bracket, and we're done. Okay, number 13. This is the same thing, but now it's a bit more interesting because it has a gap in the middle. So the domain is going to have 2 parts. It's going to have a part on the left because we got some x's over there. It's going to have a part on the right because we got some x's over there. So the domain on the left side is negative infinity all the way up to that negative 2 with a hard bracket. And, so the union sign, we have this gap in the middle, so we're going to start at positive 2 now, hard bracket, to positive infinity. So the domain here is the tricky bit. Range is easy because it starts at 0 and goes to infinity on both sides, so we just say 0 with a hard bracket to positive infinity. Now, that's domain and range, so none of that's really too tough, but look at my answer key, make sure you understand it. Let's talk about number 2 because this is kind of a throwback question. Well, for this, they give us a function f of x, and they want us to find this thing on the right, and it's pretty ugly, and it's going to get tricky, but we can do it. So the first thing that I found was f of h of x, which is here in red. All I did was replace the x in that function with x plus h, and then everything else was the same. So it ends up being 2 divided by x plus h over, or 2 over x plus h plus 1. And like I said, that's here in red. And then f of x is already done because they told us what f of x is, but I rewrote it in blue, and it's 2 over x plus 1, and so that's all done. So we have both of the things we need in order to plug them into the top of what they want. So the red goes there, and the blue goes there, and now those are plugged in. All we have to do now is simplify. Well, this is super ugly, but we have 2 fractions that need to be combined into 1. So the way we achieve that is the bottoms don't match, so we're going to force that to happen. So I'm going to multiply the left fraction by x plus 1 over x plus 1, and that's here in blue. I'm going to multiply the right fraction by x plus h plus 1 in parentheses and x plus h plus 1 on the bottom and top. And that's what I have here. If you distribute that all correctly, it should look something like this. Now, this is super awful, but a lot of stuff is going to cancel off for us, which is nice. So the bottom is going to stay the same, but we have 2x, the minus sign's in the middle, and then 2x on the right. 2x minus 2x cancels off. Then we have 2 minus 2, that cancels off. So all we're left with up top is going to be 2h, and that's over the same thing we have on bottom, and that's all being still divided by h. Now, we could FOIL out the bottom of that top fraction, that x plus 1 and the x plus h plus 1. We could FOIL that all out, and it would be a really big mess. So I'm going to keep it in parentheses, and I'm not going to FOIL it until I absolutely have to. In this problem, you're actually not going to have to ever. So save yourself that work. Okay, so I make the fraction on the bottom h divided by 1 so that I have fraction divided by fraction. And now I'm going to do keep, change, flip. So if I do that, I keep the first fraction exactly the same. I change it from division to multiplication, and I flip over h divided by 1, so now it's 1 divided by h. So we're good to go. Multiply the h straight across, or the 2h times 1 becomes 2h on top. And then on bottom, I just multiply that by an h, and it's done. Now, the only thing here that's going to cancel is the h on top and the h on bottom, so I cancel those off. So I'm left with 2 over parentheses x plus 1, and then a new set of parentheses x plus h plus 1, and that is the entire thing. That is a super tough problem. There's a lot of places to make mistakes on there, but if you kind of understand my process there, those shouldn't be too bad for you, okay? The last one that I think I'm going to do is number 24. Now, 24 is an absolute value problem. If you haven't done one of these in a while, it's okay. This one actually has an inequality sign as well, so that has another level of difficulty to it. So, first thing I'm going to do is, since the absolute value on the left doesn't have anything on the outside of it, it's isolated, we're just going to split this up into two versions. I'm going to have a red version over here on the left, and then the right version is going to be blue. So on the left version, we rewrite it exactly the same as it was without any absolute value bars. Nothing changed except we dropped the absolute value. On the right side, we drop the absolute value bars again, but we're going to make the 6 negative, and by doing that, we have to switch the inequality sign. So now it goes from a less than sign to a greater than sign. So that's the initial setup. And if you understand that, the rest of this is just basic algebra. Okay, so on the left, let's do the red side first. So to undo the 2 on the bottom, we're going to multiply both sides by 2. You're going to be left with 2x plus 1 is less than 12. Subtract 1 from both sides, you get 11. Divide both sides by a 2, and our final answer is x is less than 5.5. That's good to go. Let's do the blue side. Same thing, I'm going to cancel out the 2 by multiplying it by 2. You get 2x plus 1 is greater than negative 12. Subtract 1 from both sides. This time you get negative 13. I divide both sides by a 2, and you get x is bigger than or greater than negative 6.5. So those are my two answers. So now I need to figure out what word goes in between those. Is it and or? If they go away from each other, or in other words, if you have two regions, it's or. If they go towards each other, meaning just one region in between, it's and. So I put these on a number line. I put an open dot for both of them because there's no equality. It's not like less than or equal to, it's just less than. Okay, so open dot at both. I graph these, so x is greater than negative 6.5, so greater than numbers are to the right of it. Same thing for the red one, x is less than 5.5, so it goes to the left. So these are going towards each other, and the region that all our answers are in between negative 6.5 and positive 5.5. So we put and in between these two. Now, to put these together in a compound inequality, we put x in the middle. We put the positive number to the right and the negative number to the left. And then all we have to do is figure out which direction our inequality signs are going. The x has to be smaller than the 5.5, so that's how I got the red one. And then the blue one, x has to be bigger than the negative 6.5, and that's why, if you think about it as a crocodile jaw, it's eating the x because it's bigger. Okay, so that is the entire worksheet. I didn't do every problem, but I did the ones that I thought would cause you the most trouble. So go ahead, go through the rest of this. Use my answer key with all the stuff worked out as a helper. But make sure you get through all of worksheet 2B before the end of this week, and you should be good. Email me with any questions, talk to a friend, whatever you need to make sure that you understand everything on this worksheet. Okay? like I said, any questions, email me, and I will see you guys sometime this week. All right, talk to you later.